And there are questions 9 and 10. So I'm going to scroll all the way down. If I scroll past one that you want to look at, let me know. Just shout it out. So we're setting up equations, setting up equations, setting up equations. This one kind of leads us into what we're going to do today. So this says select all the things that have a slope of -2. We've done slope from points, right? So that's the y minus y over x minus x. 3 minus 1, 3 minus 1 over 2 minus 1, 2 minus 1. So this is going to be 3 minus 1 is 2, and 2 minus 1 is 1. That's going to be a +2 slope, not a -2 slope. And I've told you need one graph, one set of points, and one equation. So if it's not A, it must be D, right? And then we've also done from graphs, and I've got two graphs right here. They're both negative slope. If I look at them from left to right, they're both going down. Look at them from left to right, they're both going down. Here I can go 1, 2, 3, 1, 2, 3, 4, 5, 6. So this slope is going to be 3 over 6, and that was negative because it's going down, so that's -1/2. This one is going to be 1, 2, 3, 4, 5, 6 over 3. Went down 6, so -6 over 3 is going to be my choice for a -2 slope. Any questions on those two? We know how to do slope from a graph and slope from points. How did you do the equations? How did you figure out between B, C, and E the equations? Anybody got an idea? Strategy? What'd you do? Didn't know how to do it, so we just didn't do it? I don't know. I go to Desmos, and this is what we're going to do today. Oops, I don't want Desmos activities, though. I want a Desmos graphing calculator. So grab that Desmos graphing calculator. I do see something in the chat. I need to open it up, so give me a second. Oop, and that is not the Desmo I want. We are going to look over the homework after the quiz. So there's two things that I wanted to look at in the quiz, and then two things I wanted to look at in the homework. Desmos is going to be your friend, okay, guys? We need to use Desmos, but we need to use it intelligently. So if I get my Desmos calculator over here, come on now. And then I go back to my quiz. We can put in our three equations, right? 8x plus 4y equals 20. And then I can check to see what the slope is. The slope is 1, 2, 3, 4, 1, 2. So that's down 4, right 2. Is that a slope of -2 if I have down 4 and right 2? What do we think? Maybe we're not sure. So we can come and we can do y equals 2x minus 2. I'm just putting in that second equation. And then I can put in the third equation, 6x minus 3y equals 12. If you put in these three equations, you're going to see that two of them have a positive slope and one of them has a negative slope. So which one does it have to be? Anybody? The first one. Why? Because it's the only one with a negative slope. Yeah. And you can go down to right 1, down 2, right 1. The trick here is going to be to find those good points, or I call them good points, where it's a three-way intersection, right? So I've got a y line, an x line, and the function line, and they all come together at exactly 1 point. And those are that's the important part to be able to do, is find those good intersections so that you can find your slope, right? This was definitely tough because we haven't really talked about the equations. It's going to lead us into what we're going to do today. Okay, so the point was -5, 1. The equation was 8x, and then the graph was the steeper of the two graphs, because I want to go down to right one, down to right one, down to right one, down to right one. Okay, kind of our reintroduction to slope. Question number 10 was the other one that was tough. If you remember that checklist of 4 things for proving lines parallel, what was the number one thing? The angles must be, they must be what? Connected? Question mark? Does this one work? Am I allowed to go from this intersection to this intersection, going diagonally through the middle? Can't do that. So I can eliminate this one too. The first thing you want to do when you're trying to prove lines parallel is make sure you have 2 angles that are connected by a transversal. If they're not connected by a transversal, eliminate them. Okay, because now you're down to a 50-50. You need to come back up here and look and see what it's actually asking for. So if I want to prove A and B are parallel, I need an angle on A and an angle on B. An angle on A and an angle on B. So which of these 2 choices can I eliminate because it doesn't have an angle on one of the lines? D, absolutely. So now I'm going to eliminate D, and C is my only answer. I've got this obtuse angle here and this acute angle here. These are same side supplementary. They add up to 180. It's hard to see because I covered it up, but it's 120 and 60. 120 plus 60 is 180. Okay. Questions on that, guys? Any other problems on this quiz that we want to talk about? Anybody get stuck anywhere else? We did question 1. Same side supplementary. We did question 2. This is a good question to lead us into what we're going to do today. We're going to use slope in order to decide whether lines are parallel, perpendicular, or neither. All right, if there aren't any other questions, hop over to the homework and let's do 2 questions on that. Okay, so I give you a minute. I already had the tab open, which is a little unfair. So go back, get into that homework. It was question 3 and question 6 that I wanted to chat about. But again, if there's another question you want to talk about, just shout it out, put it in the chat. And here we go with the laggies. Come on, next page. The Zoom is flickering too. So if I get Terminator voice, sorry. All right. So question number 3, proving lines parallel. Where did it go? Question number 3, proving lines parallel. So we got to look at these angles, 10 and 15. So if I look at 10 and 15, they're connected with transversal M. So which lines are parallel? Which lines are parallel? If they're on transversal M, what are the 2 lines that go through M? What are the 2 cross streets? J and K. So 10 goes with J and K. If we go to the next one, 14 plus 18 equals 180. I've got 14 and 18 equaling 180. Those are same side interior. They're connected with J as the transversal. What are the cross streets to J? What are the 2 lines that go through J at those angles, those corners? M and N. So this one's M and N. So if you find your 2 angles, find what connects them, that's the transversal, and then look for the cross streets. Those are the things that are going to be parallel. Okay. Next one is 4 and 20. Come on. 4 and 20. How are 4 and 20 related? They're on transversal K. They're corresponding angles. I can slide 4 down onto 20 and 20 onto 4. What are the cross streets? L and N. Boom. Okay, so we're just going through that checklist of 4 things. They have to be connected. They have to have a true relationship. So then if we look for the last 2, let's go green. I've got 9 and 24. How are 9 and 24 connected? What transversal connects them? It's a trick. There's a trick. It's a trick question. It kind of looks like they should be alternate exterior, right? Because they're kind of on diagonals from each other. Are they connected by a transversal? Can I get from this green angle to this green angle without making any turns? Can I go on one straight road? I can't. There's no transversal here. So no lines can be proven. Are those supplementary angles or congruent angles? The green ones. Are they going to equal each other or equal 180? Equal each other. They're both acute. So both of those are smaller than 90 degrees. So they are going to be congruent, but they are not going to be able to prove any lines parallel. Which means 3 plus 7. 3 plus 7 is a linear pair. 3 and 7 are going to add up to 180 because they make a straight line. So 3 plus 7 is a true thing, but they are not going to prove anything parallel because they are supplementary, because they are a linear pair. Okay? They've got to be connected by a transversal, and they've got to be in 2 different intersections. Okay? And this just takes a little while to like wrap your head around all of these kind of logic thought processes. So the next one that I wanted to talk about was 6. Does anybody want to talk about 4 or 5? 4 or 5. Then we'll go to 6. Bug constructions. What can I eliminate because it just doesn't make any sense based on the picture? What can you eliminate? What's not happening here? Do we have congruent segments? Maybe, yeah. Do we have anything bisected? Do we have anything cut in half? Nothing's cut in half. Angles are not cut in half. Perpendicular means it's a right angle. Is anything marked with a right angle? Nope. Not going to be the perpendicular bisector either. So between congruent segments and congruent angles, we've got to decide which one is better. The trick with constructions is anytime you're making these little arcs, that's a pencil drawing something, okay? So anytime you make that intersection, the very next step is going to be to connect those things. If we connect those things, what's a more complete answer? Congruent segments or congruent angles? Congruent segments is the tempting one 100% because we've got congruent segments here and congruent segments here and congruent segments here and congruent segments here. That is 100% true. There is a more complete answer, and that's congruent angles. So all 4 of these congruent segments give this congruent angle. And that's what makes this question crazy hard, is because both of these answers are really true. It's just that congruent angles is a more complete answer. It's more specific. Okay. And we're going to struggle with these construction questions. Honestly, we'll struggle with them all term because I can't put compasses in your hand unless Math Space gets their act together and we can go do some of those practice problems. Are there any other questions about the homework? Anything else you guys want to do? Question 9. Yeah, absolutely. So question 7. Question 8. Everybody's so sleepy this morning. And yeah, we can go back to 4. Question 8. Question 9. Oh, question 9 was a big problem. All right. So we need to find the midpoint of AD. How do we find the midpoint? Do x plus x divided by 2, and then what? Y plus Y divided by 2, absolutely. So I take my x's, -1 and -3, right? If I add those up, I get -4 divided by 2 is -2. So my midpoint is going to be somewhere in -2. And then I take my y's, that's 3, because it's -1, -3, and -3, +3. So -3 and +3 is going to average to 0. Oh no. Thank you. Thank you, thank you, thank you. I had the wrong segment. Helps to read. So what's my math here then? If I do my x's -3 and +2, that's going to be -1/2. It is going to be a decimal. And then 3 and 4 is going to be 3.5. 3.5. And you can either put it in as a fraction or as a decimal. Doesn't matter. So then we go over to DC. What are we finding for DC? Slope. So if I go down 3, is that positive or -3? -3, I went down. And I go right 3, is that +3 or -3? Negative. And -3 divided by +3 is -1. This is a negative slope, it's going down. So then if we go to CB, calculate the length. How do I find the length of this line? We want to do x minus x squared. So if you do that, we've got 5 and -1. So 5 minus -1 is going to give me 6 squared. And then 1, 2, 3, 4. 1 minus -3. 1 minus -3 is going to give me 4 squared. Don't forget to take the square root. So 36 plus 16. 36 plus 16, is that 52? You want to do the square root of 52. That help? Yeah, you'll have to put that into a calculator and get a decimal. So if you open up your Desmo, you can either go down into the tools or you can do SQRT and it'll pull up a square root and then you've got your answer. Then if we go to number 4, I want A to B, but B is the midpoint, and then I'm going to extend this line down, and I want to know what this point is down here, point E. So what do I do to do that? Do I do the midpoint or do I do something else? Exactly. So we're going to make that chart, and we put the ordered pair for B in the middle. So that's -1, -3, -1, -3. And we put A, -3, 3. And then we've got to figure out what the pattern is. So what's our pattern? How do I go from -3 to -1? How do I go from -3 to -1? +2. So I have +2 more. And what do I get? And then how do I go from 3 to -3? -6. And if I -6 more, where do I end up? -9? Okay. It's really easy to get confused with all these X's and Y's. Really easy to get confused with all the X's and Y's. So let me go quickly back, well, as quickly as my computer will allow me, back to question 4. And then we're going to do a little Desmo activity. What? Oh, thank you. Come on now. All right. Question 4. The trick here is to know which table leg to look at. So if I'm building a table, I want the top of the table to be parallel to the bottom of the table, right? Otherwise, it's going to be wiggly and not work. And I want my transversal to touch the X. So you want to use this part of the table leg. How is this 70 and this X, how are they related? Are they congruent or are they supplementary? Are they same side interior or alternate interior? They're alternate, they're on opposite sides of the transversal. So this is my transversal. This is how they're connected. So are they on the same side of that line or opposite sides of that line? Same side. They're both on the right side. So if they're same side, supplementary. Same side, supplementary. I've got one acute angle, that's the 70, and then one obtuse angle that's bigger, right? So this is acute, this is obtuse. If I have acute and obtuse, acute plus obtuse is going to equal 180. So what should the answer be here? 110. Yeah, absolutely. Okay. It is, yeah. So if you see that this is obtuse, the only obtuse angle is the 110. And a lot of times, if you can kind of reason that out, these questions get crazy easy. But until you can reason them out, it's like, what am I even looking at? So it's kind of all about translating the math. So in these boxes, I want to talk about what the perpendicular slope would be. The parallel slope would be 3/4, but what would be the perpendicular slope if we change the sign and flip it upside down? I see a positive 3/4, so this is going to be a -4/3, right? There's always an invisible 1 under whole numbers. So if I turn this slope perpendicular, what would it be? Instead of positive 2/1, it would be, you guys are way too quiet today, -1/2, right? How would I turn this -7/8 into a perpendicular slope? +8/7. +8/7. How about 1? If I have a slope of 1, how do I turn that perpendicular? -1, yes, absolutely. What about a zero slope? So remember, zero slope is the horizontal line where it will sit on top of it. What's perpendicular to a zero slope? Undefined slope. Okay, that's the tricky one. Zero slope and undefined is not a number, right? Because you can't have a zero in the denominator. Okay. So what I'd like for you to do is, if your last name is the beginning part of the alphabet, I want you to find the slope for A and B. And if your slope is the end part of the alphabet, I want you to find the slope for C and D. I'm going to give you about 30 seconds to do that. So beginning of the alphabet, A and B, find the slope, y minus y over x minus x. Remember, y minus y over x minus x. You might need to get out a piece of paper. I'm getting out a piece of paper too. Y minus y and x minus x. Be careful of your signs. If you're beginning part of the alphabet, what did you get for the slope for A and B? 3/4. And if you're ended part of the alphabet, what did you get for the slope of C and D? Still 3/4. Are these lines parallel, perpendicular, or neither? Parallel. Same thing with the next one, number 2. If you're beginning part of the alphabet, do A and B. If you're ending part of the alphabet, do C and D. And when you have an answer, put it in the chat. I got a 2/5. Can anybody confirm a 2/5? Yeah? Slope of AB? What's the slope of C and D? Same thing? 2/5? 8 minus 3 is 5. And 1 minus 3 is -2. So -5/2. Are these parallel, perpendicular, or neither? Perpendicular. We've taken that 2/5, flipped it upside down, and made it negative. So parallel are going to be the same slope, perpendicular are going to be the negative reciprocal. It has to be both negative and upside down. So you got to be careful. Let's do a couple more. Make sure you're doing these on your own paper, not just waiting for us to do them. What do we get for A and B? Anybody got it yet? -12 minus 2 is -14. And then -9 minus -2 is going to be -7. What does that reduce to? Am I going too fast? Okay, I'll slow down. Anybody got C and D? So are these parallel, perpendicular, or neither? Parallel? Okay. Parallel, the slope's going to be exactly the same. So -14 divided by -7 reduces to 2, and 8 divided by 4 also reduces to 2. If the slopes of the two lines are parallel, they're going to be equal. Perpendicular, they're the upside down, they're the opposite reciprocal. So 2/5 flipped upside down to make 5/2. The 2/5 was positive and the 5/2 was negative. So let's do two more. I'll try to be more patient. If you're the beginning part of the alphabet, do A and B. And if you're the ending part of the alphabet, do C and D. You don't need to do all four. You just need to do one of them. Okay. So if you're beginning part of the alphabet, do A and B. And if you're the ending part of the alphabet, do C and D. And I see a -2/3. Which one has a -2/3? A and B for number 4. A and B. So A and B for number 4 is 8 minus 6 is 2. And -1 minus 2 more is -3. So -2/3. In the chat or shout out, what's another one? We've got 3 more to find. CD is 1/4. So 2 minus 3 is -1, and -1 minus 3 is -4. And a negative divided by a negative is a positive, so that is 1/4. Are these parallel, perpendicular, or neither? Neither. Absolutely. So they don't follow either pattern. They're not the same. They're not the opposite reciprocal. They're not even the same numbers. So this is 100% neither. What about question 5? And this will be the last one we do together like this. -1/3. N means neither. So parallel, perpendicular, and neither. That's our big question for the day. Are the lines that are formed by these 2 points parallel, perpendicular, or neither? So they're parallel if they're the same, they're perpendicular if they're upside down reciprocals, and they're neither if they don't follow either one of those two patterns. So here I got 3 minus 4 is -1, and 2 minus -1 is 3. So this was -1/3. Anybody got C and D? Three over 1? So sometimes it's easier to look at it as 3 over 1 instead of just 3. Are these lines parallel, perpendicular, or neither? Why are they perpendicular? because that's the reciprocal, and they're opposite signs, right? 1 over 3 turns into 3 over 1. A and B is a negative slope. It's going to go down. And then C and D is a positive slope. It's going to go up. Okay. That was like a rushed thing. Let's go do some practice and see if we can, and this will be self-paced practice. So if you go back into our Schoology page, and I know I have you flip around a lot, if you'd rather work on Google Slides, you can click on this link. And if you'd rather work on a Pear Deck, you can click on this link. Okay, I'm going to click on the Pear Deck. We're going to work on these for maybe about 10 minutes, and then I'm going to let you start on some green puzzle pieces. But there is one more thing that we need to kind of talk about. And you're going to need a Desmo for it. So if you haven't opened Desmo already, why is this taking forever to load? How can I find the slope between these 2 points? What is the slope between these 2 points? What's the slope there? For number 1. Up how many, right how many? What's the slope? Up 4, right 2, or up 2, right 1. So yeah, 4 over 2. And somebody in the classroom just said, well, that reduces to 2, right? So 4 over 2 equals 2. What's the y-intercept? Where does it cross the y-axis? At what number? -3. So I can write this as an equation, y equals 2x minus 3. Right? Slope-intercept form, y equals mx plus b. Vaguely familiar from algebra, right? So we're going to use these a little bit, and Desmo is kind of your cheat, but Desmos isn't always so great at that. If you look at number 2, we want to look at those good points. So I've got a good point here and a good point here. What's this slope from the graph? What's that slope? You can put it in the chat, or you can shout it out. What's that slope if I go from the left point to the right point? Absolutely, 4 over 5. Is it positive or negative? It's negative. So if I'm going to write my y equals mx plus b, y equals -4 over 5. So if you take, okay, so I always think of this as like a treasure map or a city map, right? If I start at that leftmost point, I go down 1, 2, 3, 4, and then straight over 1, 2, 3, 4, 5. You're always going to make a right triangle here. You've got to stay on the lines. You can't go off grid. Okay, so I'm going down 4, so that's -4. And I'm going right 5, so that's +5. It's a negative sloping line. So down 4, right 5. And then I need to know what the intercept is. So what is the intercept? Oops. -2. So we're going to go x and -2. Do 3 and 4. See if you can write the equation for 3 and 4. See if you can write the equation for 3 and 4. Mm-hmm. So what's our slope for 3? -1/3. Ooh, hello. And what's the intercept? 0, right? So the slope is right in front of the x. What's our slope here? And we can go this way too. It doesn't really matter which way you go. So we do 3/3. And then my intercept is +4. Okay. What I'm trying to get you to remember here is that that slope is in front of the x, right? So if I give you an equation, this slope has to be the same if it's parallel, or it has to be the negative reciprocal if it's going to be perpendicular. Okay? So let's look on slide 11. This is where you're going to put these in Desmos. Okay? So if you open up Desmos and we just want to know what the slope is, right? We could do x plus y equals 6 and look at our Desmo, and then we can find out what the slope is. All of these good points right here. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. This slope is going to be -1. Okay, so from this equation, the easiest way to find the slope is to put it in Desmos and look at the graph like we just did. Okay, do we need to practice that a couple of times? You guys talk to me. 2x minus 4y equals 28. What's the slope of that blue line? You can find that intercept, find a good point, find a good point. What's the slope there between all those orange points? ½ Okay. How are we feeling about this? Can we put the equations into Desmos and find the slopes? Yeah? Okay. Then let's go on to the harder part. I'm just not sure what you guys remember from algebra, so I need you to let me know, right? We talked about this a little bit on our slope day, the Hoy line and the Vux line. So write yourself a note if you need it, but Vux means it's vertical and undefined. Vertical lines are undefined, and they're perpendicular to Hoy lines or horizontal lines with a 0 slope. What would this equation be, this red equation? So it crosses the x-axis, that's the intercept, right? So x equals, and where does it cross that x-axis? At what number? -1, absolutely. And then if we look over at the Hoy line, where does it cross an axis? Is that an x or a y intercept? A y-intercept. And where does it cross the y-axis? At 3. So this equation is going to be y equals 3. If you have an x equals and a y equals equation, they're going to be perpendicular. Okay? And they're not in that form y equals mx plus b, so they're a little bit different to look at. So write yourself some notes if you need to like capture this information. So Vux is vertical undefined x equals, vertical undefined x equals, and Hoy is horizontal zero slope y equals. Okay. So let's see how this all comes together, because this was like a crash course in remembering equations of lines from algebra. The way you're going to see this is you're going to be given two equations, right? And you're going to be asked, are they parallel, perpendicular, or neither? Well, if they're written in that y equals mx plus b, you can just look at the slope. So are those lines parallel, perpendicular, or neither? If they both got a 5 in front of the x. They're parallel. They have the same slope, right? So it's easy if they're written in this y equals mx plus b form. It's also pretty easy, even if you've got fractions. I know a lot of students get freaked out with fractions. But still, this is in that y equals mx plus b form. So I've got a negative 3 over 2 in front of the x, and then a positive 2 over 3 in front of the x. Are these parallel, perpendicular, or neither? Perpendicular. Why? What do we do to the slopes? The sign is flipped. Absolutely. So the fraction is flipped upside down, and we've got the opposite sign, right? Perpendicular. Okay. So let's go to the next slide, slide 14. What about these? These are a little tougher. These aren't written in that y equals mx plus b form. This is where you need to use the Desmo. Or if there's another way to do it. It's just, I think, easiest if you use the Desmo. So if you get questions like this where they're not in that y equals mx plus b form, it's hard to see what the slope is here. Put them in the Desmo, and you can just type them in exactly the way you see them. X plus 2y equals 2. It's my purple line. And then 6x, hi, 6x minus 3y equals 21. Are these lines parallel, perpendicular, or neither? Perpendicular. They meet at a right angle. And if you're not sure, you can zoom in, you can zoom out. You can actually find the slope. So this is down 1. Nope, it's not down 1. But these are going to be perpendicular. Okay, and it's a whole lot easier to see it if they're in Desmo versus all of this algebra right here. Do we agree with that? Yeah. Okay. There's more practice here, but I'd kind of like to let you have the last 15 minutes to work on some of it on your own. So there is more practice here if you want to do it. But I would rather us go up here. Oh, go ahead. Yep. So if you just are given two equations like this, all you got to do is put them into Desmos and see what they look like. So like I'll do that first one, y equals x minus 3. Oops. And x minus y equals 8. Are those going to be parallel, perpendicular, or neither? These are parallel. Okay, and it's super easy to just visually see that in Desmos. Some of them do get a little tricky, but especially for these like xx and xy, this is a vertical line and this is a vertical line, they're going to be parallel. If this is a vertical line and this is a horizontal line, they're going to be perpendicular. If you're unsure and you want to check, type them into Desmos and see what the picture looks like. Okay. I know this was a whirlwind. I want to give you the last 15 minutes of class to practice. So if we go back into the folder here, this set, and you don't need to do all 3 of these. You choose 2 of the 3 to do. Okay, so you need to do 2 of these puzzle pieces. I don't care which 2 you do. If you want to do all three, it'll count for extra credit. Okay. These are the last slides, the ones that we were just looking at in the Pear Deck. So these slides right here, these questions are that first green puzzle piece. And then you've got a test review and parallel lines and slope kind of quiz. Okay, so you do any two of these. And as you have questions, put them in the chat. Let me know what they are and we'll talk about them. But the last 15 minutes of class is work time for you guys. Because I know I slammed a bunch of information. You only have to do two of them. You choose which two of the three green puzzle pieces you do. Okay. Yeah, if you want to leave the Zoom, you're welcome to leave the Zoom. Bye. See you tomorrow.